Hey guys, we're going to start looking at lesson 8.2 today. So I'm really just throwing one little piece at you today, which is really not too bad. So you'll see here on part of my screen, I've got our textbook, which you can always have open if you just go through big ideas. And I've got myself a little bit of note space on the other side, just so that I can take some notes. Because now you guys are on your own for notes. And so I'm trying to give you some guidelines and some help with that. Excuse me. So today I want you to notice that the big thing that we're changing is right in here. Okay, so now we're going to add this other letter and we're going to call it C, and you'll see why later, but we're going to add this C value to the things that we've been graphing already. So in the last section we looked at just graphing this ax squared, and remember that if a was a big number, so greater than 1, it made this taller and skinnier, it stretched it. And if it was a fraction or decimal, it made it kind of short and fat. And then if it was negative, it went from going this way and it started to open downward. So that's what that A value does, just a reminder. So now we're going to look at what that C value does. So here you can see in our book that if C is greater than 0, it's a vertical translation up. Okay, so I'm actually going to draw a picture in my notes because I need to have a picture generally, right? So here is my parent function. So this is just my y equals x squared. Well, and then I can have nothing else about the shape changes. So this is going to be y equals x squared plus c. So my positive c, it's a vertical translation up if c is greater than 0. Okay, so it's telling me if that c value is positive, it's going to shift the whole thing up. Well, so what happens if that's negative? You could probably imagine if c is less than 0, it's a vertical translation, and we want to start using these terms and these words down. Translation, dilation, reflection. You'll see these words a lot in your coming math years, so the more comfortable you get with them now, the better off you're going to be. And remember, we're always going to be talking vertical, which is kind of up and down, and then horizontal, which is our left and right. So really now that we've seen, so if that C value, doesn't matter what A is, or even if it opens down, if that C value is positive, it shifts everything up, and if that C is negative, it shifts everything down. So let's look at an example. So here we're being asked to graph g of x equals x squared minus 2, and then compare it. We're always going to be comparing it to our parent function. Okay, so what we have done in this example, and you can either do this or you can just graph it in Desmos, because I'm mostly concerned about, can you tell me what's different? Can you use those math words to compare things? So we come up with a table of values. We just pick some x's and we plug them in and we come up with our values, or we use Desmos to graph it. And here you can see the graph. Okay, so that black graph is just that x squared, our parent function. The blue graph is I've gone ahead and I've taken that and our new points. And as we saw before, the C value is less than 0, so I should shift my whole thing down, which is exactly what happens. So when we're at that part that says compare the graph, that really means we're going to be using those math words of this is a vertical translation down of 2 units. Okay, that little phrase right there, a vertical translation 2 units down, that's going to be you're comparing it to the parent function. Okay, so we've got 2 more examples we're going to look at today. So graph g of x equals 4x squared plus 1 and compare the graph to the parent function. So again, you can make your table of values like we've done here, or you can use Desmos. So what we see here is, like we talked before, this 4 in front, we want to look at everything individually. So I go from my parent function, which is the black graph here. This 4, right, is larger than 1, so it tells me it's going to be a stretch, a vertical stretch, so it's going to be kind of tall and skinny. And then I see this plus 1 right here, so it tells me also not only am I stretching it, but I'm going to shift the whole thing up a little bit. And you can see that here in this graph. So to compare, we would say that this new function, this g of x, is a vertical stretch by a factor of 4 and a vertical translation by a unit of 1 of our parent function. That's exactly what we're looking at. So let's look at this third and final example for today. So let f of x equal this negative 0.5x squared plus 2, and a g of x equals f of x minus 7, right? So now we're using that function notation again, which just tells me this thing or this function. So then I am going to describe the transformation from f to g, and then graph them both in the same coordinate plane, which just means graph them together. You can make your chart, you can use Desmos. I'm a Desmos person, so I would just graph them. Because what's more important to me is that you understand where these values are coming from, right? Not that you can plug them in and graph it perfectly. That is not a key thing. I need you to be able to see that, oh, this is negative in front of my x squared, so that tells me it's going to open down. It's a fraction or decimal, so it tells me it's going to be kind of short and fat. This lifts the whole thing up by a factor of 2. Okay, so you'll see that in the black graph right here, right? So it's upside down, it's a little bit more short and fat than the original, and then it's shifted up too. So then I see to get to g of x, I have to take that whole thing and subtract 7 from it. Okay, so what that really looks like is I just take, because it's not in my parentheses, it's not dealing with anything else, that's part of my translation down. So you can see here too that when I have this f of x in my equation for that g of x, all that means is I take everything that was originally f of x and plug that in, just like we did with those systems of equations when we learned about those. Okay, so there's our new system. Our new equation right there is still upside down. It's still kind of short and fat, but now it's just been the whole thing we've slid down some more. Okay, so that's really it, is that C value. Okay, so now you're going to be working on some of those problems, literally just looking at the examples and the equations. Tomorrow, and in the second part of this lesson and video, we're going to really dive into those kind of real world problems, because quadratics, we see them a lot actually when we're dropping things or throwing things or launching things. Those can all be modeled by quadratics, so you'll start to see those a lot. So now that you've watched through this video, you should have something similar to this in your notes, wherever those are happening right at the moment, right? Keep it kind of simple, because I'm more concerned about the practice that you're doing with this, but have this in a place where you can refer back to it. So now you're going to go ahead and work on those problems for this first part. Remember, don't submit the assignment yet until you're totally done with it tomorrow. Thanks, guys, and you got this.